Welcome to this video. It's going to be called Friday Fractions. This is a video for year 6. It's quite difficult for other year groups, so it's focusing on what year 6 have been learning before lockdown at school, revising what we've been learning, and maybe for some of you improving your understanding of what you've been doing. Before we start question 1, let me just show you these two fractions in the bottom corner. The first one, half of the circle is shaded orange. The second one, a quarter of the circle is shaded orange. Just want you to notice that the denominator, which is the bottom number of the fraction, when it's 2, there's actually more orange than when it's 4. There's less orange when it's 4, even though 4 looks bigger than 2, because denominators, if they look smaller, they're actually bigger. Halves are actually bigger than quarters. Just one little point I wanted to make at the start. Let's get going with question 1. So, you can go faster than me if you want, of course, like on morning maths, or you could work with me. The last 4 questions are really quite difficult. They're a bit of an extension. I'll just go through those quickly at the end. Question 1, easy for everyone. Just remember that if you're adding eighths, 1/8 plus 5/8, you're dealing with eighths, so the answer is going to be in eighths. You don't add the denominators. You just add the numerators, the tops. 1 plus 5 equals 6. Nice, easy start. We get 6/8. On to question 2. Not so simple. 2/9 plus 2/3. The problem we have here is one of the fractions has 9 as a denominator and the other has 3 as the denominator. So that's a bit of a problem. We need to make some changes. So I personally go to the denominator that looks the smallest, which is 3. It's not really, because thirds are bigger than ninths, but 3 looks the smallest, and I'm going to change this fraction. Some teachers would rewrite it underneath. I personally just put it next to it like this. What do I really want on the bottom? I want ninths, because then I can easily add it to this fraction, which is in ninths, 2/9. So I'm going to want 9 instead of 3. I think about what I did to 3 to get to 9. I just sing my times table songs, basically. 3, 6, 9. I multiplied it by 3. So I also multiply the top by 3. 2 times 3 is 6. So what I've done here is multiplied the bottom by 3. And to be fair, multiplied the top by 3. And I have an equivalent fraction because 6/9 is worth the same as 2/3. It just looks different. But for me, it's very useful because now both my fractions are in ninths. And I'm dealing with ninths, so ninths will be on the bottom in the answer. And with the numerators, the tops, 2 plus 6 is 8. We get 8/9. So we had a question that was a bit too difficult to do. We made a change, turned it into an easy question. The answer is 8/9. We'll move on to question 3. This is the hardest version now. We've done really easy and medium. This is the hardest version of adding fractions. 3/7 plus 1/4. And the reason it's the hardest, I think, is because one has 7, one has 4 as their denominators. I would normally try and change the fraction with what looks like the smallest bottom. What do I want on the bottom? 7. But when I sing my 4 times table, 4, 8, 12, 16, I don't get any 7s. When that happens, you actually have to change both fractions. That's what makes this, in my opinion, the hardest version of adding fractions. So a little trick you could use to find out what to put on the bottom, because we don't want 7ths and we don't want quarters or 4ths. A little trick is you can times the denominators. 7 times 4 is 28. If I put 28ths on the bottom, I can make this question work. So on both fractions, I'm changing it to 28ths. As I said, you may see some teachers rewriting it underneath like this. They rewrite the new fraction underneath, which is fine, or you can put it next to it like this. So I know I'm going to put 28ths on the bottom, but what's going to go on the top? Well, I'll deal with this side first, just focusing on this side first. What happens to 7 to get to 28? I'll count my 7s. 7, 14, 21, 28. I times it by 4. I counted and I had 4 fingers. 7 times 4 is 28. So on the top, 3 times 4, that's 12. So you times the bottom and the top by the same number. So here I've times the top by 4 and I've times the bottom by 4. And that means I have an equivalent fraction that's worth the same as 3/7. Over to the other side now. we'll be multiplying by something different. What do you do to 4 to get to 28? 4, 8, 12, 16, 20, 24 and 28. I counted on my fingers and it was 7 because it's multiplied by 7. So 4 times 7 is 28. 1 times 7 is just 7. So we have 12 28ths plus 7 28ths. That's something we can deal with. 12 plus 7 is 19 and the 28ths stay as 28ths. So we've done question 3. The answer is 19 28ths. Looking at that, that can't be simplified. It doesn't have to be anyway on this question. We're going to question 4. Going quite quick because you're all year 6, but you can always pause. You can always watch what I've said again if you're not sure. Make sure you switch your brains to minus because we're on minus now. Starting with a nice easy one, 5 tenths minus 3 tenths. Now this you do learn even in year 4, so this is not difficult work. Gets harder pretty soon though. 5 tenths minus 3 tenths, just to remind you, it's 2 tenths. You don't take away the denominators. If you're dealing with tenths, you're just dealing with tenths. 5 take away 3 is 2. 5 tenths take away 3 tenths is 2 tenths. Question 5 is more of a medium level, not as easy as question 4. Question 5 is 7 tenths, but this time taking away 2 fifths. So your brain should be thinking there's a little bit of a problem here. This happens with adding and subtracting fractions because the bottoms aren't the same. There's a little bit of a problem, the bottoms are not the same. So what do we do? Well, I'll change what looks like the smallest bottom. It's not really. Fifths are really bigger than tenths, but it looks like it, so I'm going to want 10 on the bottom. I've actually doubled 5 to get to 10, haven't I? So we're just going to double the 2 on the top. 2 doubled, 2 times 2 is 4. 4 tenths is worth the same as 2 fifths. Now it's easy. 7 tenths minus 4 tenths is 3 tenths. So you take a question that doesn't work perfectly, make a little change, and we turn it into an easy question. And we can go on to question 6. This is the hard level, the hardest level of taking away fractions. 4 sevenths take away 2 fifths. As I say, if I'm writing a bit fast for you, just pause the video and catch up, because most of you are watching this at home at the moment, I'm guessing. So, can't do this, the bottoms are not the same. We need to make some changes. I normally try and change the one with what looks like the smallest bottom. I would like to get a 7 here, but if I sing my 5 times table, 5, 10, 15, I don't get any 7s. That tells me I actually have to change both of them on this one. Using a little trick, multiply the denominators. 7 times 5 is 35. That tells me what I could put on the bottom to make this work. It's not the only option. In fact, with a lot of the work we're doing today, there is more than one way of doing it, that's for sure. But anyway, I'm going for this way. I'm going to go for 30 fifths on the bottoms. If I focus on just one side at a time, what happens to 7 to get to 35? 7, 14, 21, 28 and 35. Multiply it by 5. So if I multiply the bottom by 5, let's be fair to the top, multiply that by 5 as well. 4 times 5 is 20. So we've changed 4 sevenths into 20 35ths. Now we need to change the other side. Focus on this side now. 2 fifths into some number of 35ths. Look at the bottom. What happens to 5 to get to 35? 5, 10, 15, 20, 25, 30, 35. I multiplied it by 7. So multiply the top by 7 as well. 2 times 7. It's 14, I know you said. So make sure we do minus 20 35ths minus 14 35ths is 6 35ths. I've got a funny feeling I did plus when I did the when I wrote the answers that you'll see at the end. But never mind. I'm pretty sure this is 6 35ths now. So let's move on to question 7. Times. Now the good news is times is actually easier than plus and minus. With fractions, times is the easy one. 1/8 times 1/8. This isn't the best example because they both got 8 on the bottom. But with times, you just times the tops. 1 times 1 is 1. And you just times the bottoms. 8 times 8 is 64. But the bottoms don't have to be the same on times. If it was 1/8 times 1/7, 8 times 7 would be 56. You can just times the tops and times the bottoms. So times is much nicer than plus and minus because you don't have to change the denominators anymore. Now, if you can do number 7, you can also do number 8. You just need one little trick. This is 4, which is not a fraction, it's a whole number. 4 times 3/8. So what we're going to do is 4 times 3/8. Let's move this up a little. So you could write it as the big number 4 times 3/8. So I'm just going to turn this into a fractions question very simply. 4 is not 4/10, is it? It's not 4/100ths. It's not 4/1000ths. It's not 4/8. What is it? It's 4 ones, isn't it? It's 4 whole ones. 4 units is 4 whole ones. So it's the same as 4 ones, isn't it? 4 whole ones. So if you just put that little line, which means divide, by the way, and the 1 on the denominator, you've just changed your 4 whole ones into 4 ones, which is the same, isn't it? But it means we can very easily multiply the tops, times the tops, 4 times 3 is 12, times the bottoms, 1 times 8 is 8. And we get 12/8. That's a top-heavy fraction, because the top is bigger than the bottom. It's a top-heavy fraction. I have a little picture of that over here. Little picture of 12/8. So my bits are in orange, okay? 12/8 is 1, 2, 3, 4, 5, 6, 7, 8. That's 8/8. 9/8, 10/8, 11/8, 12/8. That's a picture of 12/8. Can you see how I've actually got 1½ full circles? Because 12/8 equals 1½ It also equals 1 4/8. So there's lots of different answers that are correct on this one. 12/8 is correct, 1½ is correct, and 1 4/8 would also be correct. Let's move on to question 9. This is 2/5 times 10. I'm going to use the same technique, but I'll be coming back to this question later. But the same technique, 2/5 times 10, is the whole number 10. This is 10 whole ones. 10 whole ones. So now we can just times across the top and times across the bottom. 2 times 10 is 20. 5 times 1 is 5. Another top-heavy fraction, 20/5. 20/5. That you always have to simplify because 5 will fit into 20. I've got a picture of 20/5 right here. You can see I've got 5/5, 5, 10, 15, 20/5. It's 4 whole ones, isn't it? Because 20/5 equals 4 whole ones. And in the SATs, if you were to do the SATs, they want you to write the whole number because it's a much more usual version than 20/5. Another way of doing that is you could sing your 5s up to 20 and you'll see it fits in 4 times. 5, 10, 15, 20. Because 20/5 equals 4 whole ones. Let's move on to question 10. Question 10, divide. Now divide is too hard really to do. It's really, really hard to divide fractions. So we have a little trick to do this for us. 3/8 divided by 2/5. And you were taught in school, I believe, the KCF method. Did I say that right? KCF, yeah, keep, change, flip. Not KFC, KCF. Keep, change, flip. Because divide is too hard to do. So we basically don't do it. We change it to times. We keep the first fraction the same. We change the sign to times. So I basically cross it out with the time sign. And then we flip the second fraction. We flip it. 5 goes on the top, 2 goes on the bottom. If we do that, we've turned this question into times. And as I said before, times is nice and easy. 3 times 5 is 15. 8 times 2 is 16. And our answer is 15/16. We'll do another 2 of these. Very similar anyway. On to question 11. Question 11 is 5/6 divided by 4. 5/6 divided by 4. I'm going to use the same KCF method. 4 is, of course, 4 whole ones. So just change it into the fraction version of 4 whole ones. Then we can do KCF. Keep, change, and flip the second fraction. 1 goes on the top, 4 on the bottom. Now, It's just a times question. 5 times 1 on the top is 5. 6 times 4 on the bottom is 24. There's no simpler version of that. 5/24 is the answer for this one. On to question 12. The only difference with question 12 is that the big number is at the front. The whole number's at the front this time. 5 divided by 4/7. That's really too hard to do. So we do our little trick. 5 is 5 whole ones. Then we do the KCF. Keep that one, change the sign, and flip the second fraction. So keep that, change the sign to times, which is nice and easy. Flip the second fraction, 7 on the top, 4 on the bottom. We just flip it, and then the question's easy. By the way, never flip anything except divide. Remember that. Don't start flipping everything else, plus, minus, times. No, only flip divide. 5 times 7 is 35. 1 times 4 is 4. So we get 35 quarters. That's a lot of quarters. I think I'll change that one into a mixed number. 35 quarters. 5 times 7 is 35. 1 times 4 is 4. Okay, so I'll sing my 4s. 4, 8, 12, 16, 20, 24 and 28. And 32. That's 8. 32 of those quarters makes 8 whole ones. And then I have 33, 34, 35, 3 quarters left. So 8 and 3 quarters. Question 12 is 8 and 3 quarters. On to question 13. This is easy. Really easy. So easy you might not even get it. 4 plus 5/8. What's 4 and 5/8? Well, it's 4 and 5/8. 4 and 5/8. 4 plus 5/8. Plus means and. 4 and 5/8. Just to make sure, I could have fit that on the top line, I think. Just to make sure you understand that. Maybe not. That's just about right. 4 plus 5/8 equals 4 and 5/8. On to question 14, which is a bit more difficult. Question 14 is 7 whole ones take away 1/5. 7 take away 1/5. Now, what I'm going to do, I think, here is change this 7 into fifths. There's a lot of fifths in 7 whole ones. Here's 5/5 in 1 whole one. 10/5 would be 2 whole ones, wouldn't it? 15/5 would be 3 whole ones. 20/5 would be 4 whole ones. It's just the 5 times table. 5, 10, 15, 20, 25, 30, 35. 7 whole ones is 35/5. So I'm going to change the whole thing into fifths. 35/5. Because then it's a really easy question. 35 take away 1 is 34. We're back to minus here, aren't we? 34/5 being the answer. And we'll simplify that because we can get lots of whole ones when we've got a very top heavy fraction like this. I'm going to sing my 5s. 5, 10, 15, 20, 25, 30. That is 6 whole ones using 30 of the fifths, and I have 4/5 left over. 6 and 4/5 is the mixed number answer. But this one is actually fine because top heavy fraction, when they're marking the sats or anything like that, they're okay as long as it doesn't go exactly into a whole number. But if you're not sure, if you don't know when to simplify or when not to, you could just simplify everything if you know how, and you get 6 and 4/5. Let's move on to question 15. More simplifying. This one we've basically already done. How do you simplify 20/5? Well, one way of simplifying is divide both these numbers by the same thing. So what number fits into 5 and fits into 20? Well, 5. We can divide them both by 5, and we get 4/1 divided by 5 divided by 5. 4/1, 4 whole ones is of course 4, isn't it? So the answer is 4. That's one way of doing it. Or, the answer's 4 anyway. You could sing your 5s up to 20. 5, 10, 15, 20, and you get 4. Either way, it's 4. This is connected to question 16, which is actually very similar to question 15, isn't it? This time it's 21/5, not 20/5, 21/5. These green pictures here, they're divided into fifths. 1, 2, 3, 4 whole ones is 5, 10, 15, 20 fifths, isn't it? You can see 20 little green bits in all these 4 circles. That's why on question 15, 20 fifths equals 4 whole ones. But what if we had 21 fifths? Well, means we just have another fifth. In the next circle, we only have got 1 of them. We haven't got all 5 like before, just got 1. So we've got 5, 10, 15, 20, 21 fifths. How many circles have we got? We have got 4 whole circles, 1, 2, 3, 4, and then just one little remainder, 1/5 remaining. So it's 4 and 1/5. That's how we'd simplify that. That's how we would change this top-heavy fraction into a mixed number, mixture of a whole number and a fraction. Okay, question 17. We've basically already done this because it's here. 2/5 times 10, 2/5 of 10. In maths, of means times. Of means times. Do you hear that? Of means times. Okay? So, when you're doing 2/5 times 10, it's the same thing as 2/5 of 10. There's just loads of different methods of doing it. So, question 17, I'm probably going to do this in 4 different ways, this question, to show you what's going on. So, 2/5 of 10. I'll do it in a picture form first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 little shapes here. We want 2/5 of them, which means you get 2 out of every 5. So if you see 5, that's not very accurate. See, can't draw today, can I? There's the first 5. I'm going to get 2 of them. 1, 2. Then there's another 5 over here. I'm going to get 2 of them. 1, 2. What's my answer? 2/5 of 10 equals 4. I ticked 4, didn't I? If you take 2 out of every 5, you get 4. That's one way of doing it. Another way of doing it, I don't know if I wanted to clear all of that. Another way of doing it, 2/5 of 10, is you find 1/5 and then you change it to 2/5. So 1/5 of 10, you take 1 out of every 5, take that one from the first 5 and that one from the second 5, and I get 2. So I found 1/5 of them by taking 1 out of 5, then I just double it, 2/5, and I'll get 4 again. And the answer will be 4. Okay? We will often use just numbers instead of shapes, especially because as the numbers get more complex, you can't really do everything in shapes anymore like you did in year 3 and 4. So we'll say 2/5 of 10, we'll say divide by the bottom, 10 divided by 5 is 2. Okay, when you divide by the bottom, you're finding a fifth. 10 divided by 5, you're finding 1/5. Then you get that 2 that you just found, times it by the top, and you get 4. So teachers will often say, divide by the bottom, and then whatever you get, you times it by the top. Divide by the bottom times by the top. That's a great way of doing these fractions of a quantity questions, fractions of a number. Earlier when we did question 9, we did it a different way, didn't we? When we did question 9, we did 2/5 times 10. We did 2/5 times 10. We put the 10 over 1. 2 times 10 was 20. 5 times 1 was 5. You get 20/5. Then you have to divide that fraction at the end. 20 divided by 5. 5, 10, 15, 20. Oh, what a surprise. It's 4. Because whichever method you use, you're going to get the right answer. So there was 4 methods for doing the same thing. You only need to know 1, really. But if you know all 4, you're going to have a great understanding of what you're doing. Right, it's been a long video today, so I think I'm going to leave the extra 4 questions for you people who needed an extension. You can see how you got on when I reveal the answers. So let's reveal all the answers now. You can mark what you've done to see how you got on. There's all the answers. Next time I do this, because I'll be able to go faster on the first 17, I will actually go through the last 4 questions. But today I'll leave that just for the people who need a challenge, because they're the hardest ones. So do your marking just like you do on morning maths. And I'm planning to do one of these each Friday. So I'll slightly increase the level as we go on each Friday. Although really, we're getting, with those last 4 extension questions, you're getting to the hardest thing you need to do in any arithmetic SATs that you ever have to do. I'll see you again next time we do Friday Fractions.